Hi, my name is Nick Borson, and this is the third in a series of videos about learning to program using PowerShell. These videos are aimed at non-programmers who want to learn how to code, and they kind of build on each other, so if you haven't already done so, you might want to go back and start at the beginning of the series. I'll include a link to the playlist in the description. So in this video, we're going to learn how to create our first script. In the last time, up to now, we've been just typing PowerShell commands, add a PowerShell prompt, and executing them immediately. In order to create a script, we're going to create a text file, and we're going to type commands into the text file. Then we can invoke the text file, which is our script, and execute all those commands at once. So to do this, we're going to need to use a text editor program that we can type our text into. This is a program for editing text files. And a text editor is different than a word processor like Microsoft Word. A Word document contains text, but it's not a text file because it has a lot of other information, like formatting information that's not just text. A text file is literally just a sequence of characters. Text files are often used in programming, and there are a lot of text editors that are really designed for programming uses. The one I would recommend using is called Visual Studio Code. That's what I'll be using for this demo. And you can download it for free on all the major platforms. I'll include a link in the description. Okay, so here we are in a PowerShell prompt, and I'm going to put all of my scripts in a directory called Learn PS. So I need to create a directory for that purpose. You may notice that when we have the prompt, I haven't really covered this before, but each line, when PowerShell is prompting us for input, it displays PS for PowerShell, and then it shows the current directory. So this is the folder that is the active folder right now for PowerShell. So if I were to get a listing, type the ls command and get a listing of files, it would show the files in that folder. And likewise, right now I'm going to create a folder. I'm going to use the makedir command, mkdir, and then create a folder called Learn PS. And it's created the folder, it's returned information about the folder that it just created. So it has the directory attribute, it has this last write time, and it's called Learn PS. Now I can call set location, which is sort of location. No, it's called set current location. Oh, anyway, the short name is CD to Learn PS. I can just type learn and hit tab. And so the argument to changing the directory is the path. This is using the dot means current directory, backslash is just a separator. So we're going into the Learn PS subdirectory under the current directory. Okay, so that was all just in order to create a directory and move into it. It becomes more natural over time. It doesn't sound as painful as it's not as painful as it might seem. Okay, now I want to run Visual Studio Code so I can create my script. So I'm just going to type code, which is the name of the program, and I'll type dot because I want to open the current folder in Visual Studio Code. So there we are, Visual Studio Code starts up with the current folder open, and it tells us the name of the folder that it has open up there. Now I'm going to create a new file. I can go to the File menu and select New File, or I can hit Control-N. And before I do anything else, I'm going to go ahead and save the file. So I hit Control-S, or I could go File, Save, and it's going to prompt me for a name, and I'll just call it first script.ps1. So the .ps1, instead of a txt extension for a normal text file, I'm going to give it the .ps1 extension, which means that this is a PowerShell script. It's a text file, but it should be interpreted as a PowerShell script. Okay, so let's just put in a couple commands. I'll say hello world. Oops. And this is my first script. Okay, I'm going to close that. All right, and then we'll try running it. So I can just type first, hit tab to autocomplete. And now I'm going to invoke my first script. Oh, well, you might have this error. If you're running on a Windows computer, you might see this error the first time you try this. So this is telling us that it cannot be loaded because running scripts is disabled on this system. So in order to protect people from accidentally running scripts from malicious users, PowerShell in Windows has what's called an execution policy, where by default it disables running all scripts, or at least unassigned scripts. So since we're going to be making scripts, we want to be able to run them. So I'm going to change the execution policy, and I can use the set execution, I hit tab to complete that, set execution policy. And I only want to set it for my own user account. I would need to set it for the whole computer. I'd have to have administrative access, but I can set it just for the current user by saying scope current, tab current user. And I'm going to set it to, I could set it to unrestricted, which means that it will run any script, or I could set it to remote signed, which means that in order to run a script from a remote location, like run a script off of the network or something, it has to be signed. But for local scripts, it can run them without being signed. Okay, now I can say first script, and all it does is executes the two statements that I included in my script. It just goes from top to bottom. That's the way that the control of the program flows, is just from top to bottom. So it executes the first command, and then it executes the second command. Okay, so that was pretty simple, but let's try to do something a little bit more interesting. Suppose I want to read a value, I want to prompt the user for a value, let's say the user's age, and then I want to perform some sort of calculation. For example, let's say that I want to ask the user for their age, and then I want to tell the user how old they were in the year 2000. All right, well, we've done some of this before. We've used the, I'm going to clear the screen so it's not distracting us. I typed CLS or clear and hit enter. We've used the read host command before. So I could say age equals read host. I can have a prompt. Enter your age. Okay. And then the user is prompted with the string that we typed here, and the user types 40. And now the value that the user entered, the string the user entered, gets assigned to the age variable. So now if I type age is 40. Okay, so that's going to be the first part of our program. We're just going to prompt the user for their age. So in fact, I can just literally copy this, Control C, and paste this into my script. And we're prompting the user for their age. That's the first thing the program does. And just to explain, so in a script, it's often useful to add comments in the script so that somebody reading the code, including yourself as you're working on it, can more easily understand what it's doing. So get the user's age. Okay. Now, we want to be able to compare the user's age with the year. Let's see, we want to find out how old the user was in the year 2000. Well, in order to do that, we need to know how long ago the year 2000 was, which means we need to know the current year. So to find out how long ago the year 2000 was, we would subtract 2000 from the current year. So how do we find out the current year? There is a getDate command. GetDate. I'm going to hit tab to autocomplete. Hit enter. Okay. So there we are. We have getDate. When I typed getDate, it output a message that it said the date in this kind of format, which is sort of the typical format for English in the United States. And you might think then, okay, so the next step would be we have this string and we need to kind of figure out what part of the string is the year and pull the year out so we can then do something with the year. And that is maybe what you'd have to do on some, if getDate was literally just returning a string. But in fact, getDate is returning an object that has a number of different properties. So just to show this, let's assign the return value of getDate to a variable to make it so we can expect it more easily. So getDate, date equals getDate. So now date is a variable that has the return value or the output of getDate. And again, we can just type date and see the same thing we saw above. But we can also say, what is the type of getDate? Say date get type. So we're calling we can call the getType method on any object to get a type object. And then we can ask its name, refer to its name property to get the name of the type. and we see that the date is not a string, it is a datetime object. Okay, well that's a hint that maybe this datetime object has some properties that are interesting to us. So to find out what those are, an easy way is to say date, and then we use this vertical bar symbol, which is sometimes known as the pipe symbol or the pipe operator, and we'll type format list. Okay, what does that mean? So the expression on the left is evaluated. In this case, it's just a variable, so the value of the expression is the actual datetime object. Then we take the output of this expression and pipe it as the input to the next command. So the format list command takes the input that was received, takes the datetime object in this case, and then it formats it as a list, meaning each item, each row of the list is going to be one of the properties of that object. So for each row for each list item we have the property name and the value. So the datetime object has a display hint property, which doesn't really mean anything to us. It has this date string, which is the date with no time, just the date only in this format. It has a datetime string. This is the same string notice we saw up here. So there's this datetime property. When you get the datetime property, it gives you a formatted date and time. But it also has these individual properties for day of year, day of week, hour, millisecond, minute, month, second, etc. And what we want is, of course, the year. So we can say date.year, referring to properties of an object using the dot notation. And there we are. We have 2021 as our current year. We don't have to assign the date to a variable. The thing to the left of the dot can be any expression. So we can say get date, enclosing it in parentheses to make it clear that this is its own expression. And then that's going to return a datetime object, so we can refer to its year directly. Okay. So let's put this in again. So we'll get the current year. So current year is equal to, and then we'll invoke the getDate commandlet to give us a datetime object. We'll put it in parentheses to make it clear that this is being used as an expression. We're going to access a property, and specifically the year property. And the year property then of this whole thing, this whole expression now evaluates to the year property of the datetime object, and that's going to be assigned to our current year variable. So get the current year. All right. Then we have the current year, we have the age, and we also want, we also want the target year, what I'm calling the target year, which is the year that the year that we're trying to find out the user's age as of. So let target year be 2000. And I'm just going to hard code that to 2000. And then we want to find out the age as of the target year, so we're going to call that target age. So this is just going to be a calculation that depends on these other values. So let's see now. We have the current age, and then we want to subtract the difference between the current year and the target year, right? So the target year was, if the current year is 2021, for example, and the target year was 2000, then the target year was 21 years ago, 2021 minus 2000. So with that 21, that distance, that difference in those years would be subtracted from the age to give us the target age. Okay, so let's try that. Age equals current age minus current year minus target year. Okay. And then finally, we are going to write our message, and we're going to display it. We're going to use the write host command because we want to output this message to the user. And we'll just say, on this day in target year, you were target age years old. we'll say display the result to the user. Okay. We're using write host because we're displaying to the user, as opposed to write output would be just writing the result to the output. Write output might actually be more appropriate in this case, who knows. Anyway, so one thing I want to point out here is that in this string, we've embedded variable names in the string, and you notice that they're a different color. That's to indicate that PowerShell is recognizing these as variable names, and when we write this string, it's going to expand these variable names. It's going to replace the variable names with the actual values of those variables. If we didn't want that to happen, if we didn't want that expansion to happen, we could use single quotation marks around the string, and that would mean that this whole string is treated as just a literal string. So we'd actually write out target year and target age to the output. But we want, in fact, to write out the values of those variables in place of, we're using these as placeholder values that get replaced with the actual values, and so we use double quotation marks. Okay, so let's try running our script, and we'll see what happens. So to run the script, again, we just say the name of the file first, and I can just hit tab to complete that, hit enter, enter your age. I'm going to lie slightly and say I'm 35. And on this day in 2000, I was 14 years old, because 35 minus 21 is 14. So that makes sense. That works pretty well. What if I said something else? Like if I said, enter your age, and I said I'm 12. Well, in that case, 12 is less than 21. That means 21 years ago I wasn't born yet, so it's going to actually just end up with a negative number. So I think that's okay for the script to just show a negative number. I could have displayed a different message like, on this day in 2000, you were still 9 years away from being born or something. But instead we just say negative 9 years old. That's fine. What if I say, run the script again, and I say, enter your age, and I type ZZZ? Well, that's not a number at all. Can't convert ZZZ to type int32. Okay, so this particular script isn't handling that case, and that's good to know, but I think that's something maybe to cover in the next episode when we go into conditional statements. So there we are. We've written our first PowerShell script. We used a text editor, in this case Visual Studio Code. We created a file, a text file. We gave it the .ps1 extension. That identifies this file as being a PowerShell script. We used PowerShell, we just typed PowerShell commands into our file, and they were just executed in order from top to bottom. In the next episode, we'll see that that's not always the case. We can actually control where the flow of control goes. It's not always from top to bottom, but the default is from top to bottom. And what we did was asked for the user's age. We got the current year by accessing this datetime object. We computed the difference between the current year and our target year, and then figured out what the target age was. And finally, we wrote a message to the output, or to the host, to the user, showing the result. And there we are, our first script. So this gives you something to play with. You can maybe experiment with creating your own scripts, and next time we'll modify this script to do something a little bit more advanced. It will handle error cases where the user doesn't enter a number, and we'll also maybe try entering more than one thing into the script. All right, enough for now. Thanks for tuning in, and see you next time.